So welcome to the internal working of Flutter animations. Today we want to peer underneath the Flutter animation framework and actually look at how the components that make up this framework interact to give you the output you need when creating a Flutter animation. Now, it would be helpful if you've created a few animations, explicit animations in Flutter, because it would give you that means you would have a good understanding of what these things are, and maybe even the problems that you faced because you couldn't understand what some things do. But even if you have not done anything in animations yet, it is still not a bad idea to listen to these kinds of things, because once you have a basic idea of how these things work underneath, it genuinely gives you a solid grasp of how they work on the top. So, so we're gonna start from the basics and work our way towards the actual internals. But just before that, I just a bit about myself. So I work in a company called Baitfinder, and we're based in Austin, Texas. So we have a lot of Flutter-based products for mainly for now mainly the fishery industry in the U.S. And we have a lot of projects upcoming as well. And most of our stack is Flutter, apart from web at this moment. But we are looking to transition more things to Flutter, and try to unify our code base as a whole. I am a technical writer for Flutter since Flutter was an alpha, just around the time it came to beta. And I write on Medium, and I've been writing on Medium for a long time now. And I started out with these deep dive kind of articles, and they pretty much got a bit of traction, and it just seeing the response of the community just made me want to write more and more. So mostly I write on Medium and some other blogs like Code Magic, and there's a lot of blogs that I've written mainly Flutter content for. I also since Hack 20 is probably tomorrow now. I also won the first Hack 19 that was last year internationally, and overall that was also a great experience. Um, Mostly my experiments are on Twitter, and we'll get to that at the end, because we don't really want to we want to get to the content as fast as possible. Okay. So first of all, what is an animation? So an animation is really defined in terms of state change, if you can say that. What I mean is, an animation is really trying to, if you think about it, there's no direct purpose for an animation. An animation is made for humans. It is not, there's no objective purpose to animations. So for example, if you have a box that changes from 10 to 100, that box, an animation would change that box gradually from 10 to 100. So it would not go from 10 to 100 instantly. It would rather be a gradual change in state of the box size or the box length or whatever, that would go from 10 to 100 over time rather than just going instantly. So that is the basic concept of an animation, a gradual change over a long time, relatively long time. Um, so then there's like many kinds of animations, which are like it can be a change like in visibility, it can be like a fade in, fade out, it can be a size change, it can be a color change. It can even be a combination of many types of animations. And there's Flutter offers like easy way to do lots of this. And but underneath it, we just want to understand how does Flutter actually empower us to create all of these. So that's what an animation is. Now, like we said, um, an animation really when we say an animation, we want to think about how the values change. So, and more how the values change over time. So we want to interpolate at at this instant in time, what will the value of this animation be? So for example, if you start out with 10 and you want to end up at 100, then at half the time, what is the size? At one-fourth of the time, what is the size? So this change, when you can get this change, it will allow you to get what is the animation value right now, and that will make your user feel, okay, this is a gradual change from A to B. So in order to do this, we need to interpolate values between start and end, or begin and end points. So this is easy enough for color. So this is easy enough for sizes, which you just go from 0 to 100. If there's 100 seconds and I want to do it, if I want to change from 0 to 100, if there's 100 seconds, I can just do like, for the first second it'll be 1, second it'll be 2. So it's very easy to see how doubles or like normal values can be interpolated, but things like color become more complex because going from blue to red, it's not a very easy thing that your mind just imagines. Whereas going from 0 to 100, you objectively just know what is the next value. So the main trick to animation is interpolating values. Okay, so an essential concept in Flutter animations is a tween. So tweens they stand for in betweening. So tweens help you find this value. So any value between your begin and end. So if you're going from 0 to 1, they help you find, if your duration is 1 second and 0.5 seconds, what is the current value. So tweens help you find, let's just say, the values in between to the begin and end. And so tweens can evaluate values at certain points, and tweens can return animations. So for now, we've talked about two Flutter objects, and if you've done Flutter animations, you'll be pretty familiar with these two, which are tweens and animations. Now, as a beginner, it can get very, very there's not an easy way to understand what each one is doing, and that's what this talk is kind of trying to explain. So essentially, we want to have a gradual change in a value to display on the screen. So we have, for now, we have two concepts. We have a tween and we have an animation. So let's try creating a very basic animation, like a very basic animation to change the size of a square, for example. Now, when we go, so this is a basic, pretty basic Flutter app. And let's observe what are the singular things that we need to change when we're creating an animation. So the first thing which you'll probably notice is that we need to add this. So a single ticker provided state mixin. It's a bit of a mouthful, but so this is very essential. We'll go into why later. The next thing you need is an animation controller. So we've said, so an animation controller, for now, let's just say it controls the animation. So it starts and stops or whatever. Let's just say for now that an animation controller controls an animation. The second thing, what we talked about with tweens, you don't need to define one, but for now we'll just define it for clarity. So we'll make a double tween. So we want a value to go from, so this basic app just creates a square of 10 by 10. We want this to go from 10 to 100. So let me just refresh, sorry. Yeah, so now you have a very small square of size 10. Now we want this to go from 10 to 100. So first we'll define a tween. Like we discussed, a tween gives you values between a begin and an end at a certain instant in time. Now, so we want it, let's just call it tween, and we begin at 10 and we end at 100 because that's our begin and end for the animation. And the last part is the animation. For now, let's just name it animation. Now, we've not defined the animation controller, so let's do that. We need to give it a duration. Let's just have 1 second. and we need to give it vsync. Okay, so so till now, what are the main concepts we've dealt with? One is the single ticket provider state mixin. The second is an animation controller. The third is the tween. The fourth is an animation, and then there's this vsync thing. But okay, so the tween is already defined, and you get an animation from tween.animate, and you pass in the parent, which will be your animation controller. So the reason I'm not explaining this much is like for now, I want everyone to have a simplistic view of it, and then we can go in depth. So the simplistic view here would be there's an animation controller which controls the animation. There's an animation which we want to run, and that animation runs on the tweens values, which begin at 10 and end at 100. So one of the last things we need to do is we need to use the width and height. So we need to use the animations values for the width and height of the container instead of that. And it won't, and right now if you run it, it will not run because we are not actually doing anything. We're not actually refreshing or rebuilding the UI when an animation value changes. So just bear in mind this is a bad practice to just complete. So don't use add listener and just set state because it refreshes the whole UI. But right now, right now it just helps explain the point. So for now, it's okay. So we're using this to just refresh the screen when the animation value changes. An animation controller is responsible for starting the animation. So the animation controller, we need to actually, so forward actually starts the animation. Add listener refreshes it. This creates the animation. This creates the animation controller. So good enough for now. If we run it, so we get a square that expands from 10 to 100, right? Now, just let's just isolate these things. So now we actually want to look into what we've actually done. The animation controller good enough, but what is vsync? Why do we need an animation controller at all? Why can't we just have like animation.start? What is this tween doing? And in the end, what is this thing? And you can also use ticket provider state mix and a single ticket provider state mix, and either way, that's a mouthful. So we want to actually find out the differences in the purposes of all of these. So we just did this. We just did a basic animation so that everyone gets to the same level in terms of how a basic animation in Flutter works. So we've done this. Now let's just go back. So we've looked at a very basic animation example, which involved tweens, animation controllers, and animations. So to recap, animation controllers control the value, tweens set the begin and the end, and give you the values in between, and animations give you the value to use inside the container or the rebuild, the UI itself. Okay. So the question is, if tweens have a begin and an end, and they can tell us what the value is at a certain point, are tweens animations? So the question is more this. The tween here gives us a begin and an end. And since I wrote that tweens also give us a value in between, can the tween work in place of the animation itself? So um, let's try it. Let's just remove this animation as a whole. Now, let's see if tweens have anything. So tweens have the transform method. So transform is a method that takes a time t, tween.transform and time t. So this time is when at what instant we want the value. So we have a tween with begin and end. What that transform method is asking is at what instant do you want the value of tween? So at 0 it would be 10, and at 1 it would be 100. So To understand this, but let's just go back a bit and let's look at animation controllers first. So again, what really are animation controllers? I mean, why do we need them? Why isn't there just a start method for animation? So this is the simplistic view of it. A controller controls an animation controls a widget. So when the animation changes, the widget changes, the controller starts as animation, blah, blah, blah. So what we can say is the animation controller controls or drives the animations. But again, what does that really mean? I mean, there's no real definition to it. So when we create an animation from a tween, we pass a parent. So here, when we pass in, for now, we'll just go back a bit. Okay. So when we were creating this animation, we pass a parent. Now, what is this parent? I mean, is it does it are there some kind of callbacks defined that start the animation? Are there like, so what does driving it mean? So here's the crux of the entire situation. An animation controller is an animation, which is weird. An animation controller is actually an animation from 0 to 1. And that's really weird to hear. Because imagine if a Google Map controller was actually Google Map. And that's, I know that's ridiculous, and that's kind of the point. So if an animation controller is an animation, what is exactly happening? So let's go back, and now we have a whole other way to look at it. And I agree it might be even more confusing than what is earlier. And that is a phase to understanding this fully. So what we're saying now is that we have some kind of animation that does 10 to 100. That's good. But now what we're saying is this is also an animation. And if that's an animation, then what's driving that animation? So this is an animation that is driven by the animation controller. But what we're saying now is an animation controller is actually an animation. So the question is, what is driving the animation controller? So a tween is an object that you can tell the intermediate value between a beginning and an end. Meaning you had a beginning 0 or the end 100, and at any instant in time, it can tell you what is the value. An animation takes a parent animation double. So this animation, when in the this tween in the animate method actually wants another animation. And to understand this better, let's just remove the animation code for now. So earlier we were listening to animation and we were adding a listener to the animation, but now we're saying that the animation controller is itself an animation. So why can't we listen to animation controller? And we can. So what we're saying is the animation controller is an animation that runs from 0 to 1. So this makes so now let's just remove the animation altogether then. Now we have a time. So let's do um, tween.transform like we did earlier. And now let's try using the animation controller's value. Now let's run this, and it works exactly the same. So what's happening here? So the tween.transform method is a method that takes a value from 0 to 1. 1 meaning completed, 0 meaning like the beginning. So what we're saying is, what is the tween's value when the animation controller is at this value, whatever the value might be. So it might be 0, it might progress up to 1. So um, we're running this animation controller. The animation controller, when we set it forwards in motion, the animation controller goes ahead. So it goes from 0 to 1. And we listen to changes in the animation state. And then for everything, we wrap it. And for every animation value, we get the tween's equivalent value. And this gives us a big hint into what an animation actually is. So an animation is basically a tween. It is not much more. An animation is basically a tween, but with some added features. So what are the added features? If you noticed, when we defined an animation, when we actually defined the animation and we had something like, let's say animation.value and the same over here, we did not have to pass an instant in time. So like we do over here, we did not have to pass a value from 0 to 1, but the reason for that is that it is taking it. We are already providing the animation controller to the tween or to this animation to get to get the value out of implicitly. So in summary, an animation controller, sorry, the an animation is a tween with it's a wrapper around a tween in some sense. So it wraps a tween, and what it does is it gets the animation controller's value, and it doesn't make you actually calculate the values on your own. So calculate the tween's equivalent values on your own. But then what does it make you do? So the added feature of it is that an animation helps you uh, listen to it. So when you look into the internals of an animation itself, what you will spot is it extends listenable. So the main purpose of an animation is one, to give you the values without you having to calculate them from a tween, and the second is to notify you when that animation value changes. So so in summary, the animation value, so the animation itself, an animation is a wraparound tween. A tween carries some values and gives you intermediate values, and an animation gives you a way to listen to changes. So when I said adding a listener here is bad, that's because the a better method is, if this container changes, we can basically wrap it with animated builder, and then we can listen to an animation, which here would be animation, and then we can just get snapshot.value, for example. Oh, sorry. Then we can just get animation.value, and now without even listening to it, we can just observe this animation. This is not possible with the tween because the tween does not allow us to listen to it. The only way to do it would be to return an animation. And since we said an animation controller is also an animation, you can do it just fine. So you can also listen to an animation controller or an animation. The advantage of this being there is that you can now build certain elements like this container, and only this portion of it will build. Everything else will not rebuild because and that saves you that just makes for a more efficient app since your entire UI is not being rebuilt. Okay, so back to the main question. If the animation controller is an animation, then what drives that animation? So for now, we've established how everything works after an animation controller says go ahead. But when it says go ahead, what is driving that forward, right? So tickers. So now we go into the part that we discussed that we saw over here. What is the single ticker provider state mixin and why is it so long? So to drive the animation controller from like, let's say 0 to 1, we use tickers. So like the name, tickers provide ticks. And on every tick, the animation controllers get the time from the start, meaning they get elapsed time. They don't just they don't they for example if your device let's just say in an ideal case your tickers would run, let's say, once per second, but for some reason if your animation is too heavy or I don't know, something goes wrong, your phone is slow, something happens, and your second tick happens not at 2 seconds but at 2.5 seconds. At that instant in time, your animation controller will actually get that 2.5 and it will calculate that I need to be at 2.5. I cannot be at 2. So even if the animation runs slowly, if the frames render slowly, the animation does not go slower. So um, the main thing is the animation runs on time, and even if the frames drop, the animation, so a 1 second duration animation does not turn into a 2 second or 3 second duration animation. So in the worst case, if something goes wrong, then it would just become more. It would just the frames would drop, but the duration would not change, and that is essential to a lot of different cases because since in a Flutter app, if you have some UI elements that are which have some interaction between them, then it becomes really hard when the duration of the animation is extended. So, um, hmm, and yeah, so they calculate values in elapsed time, and slower frames don't make the animation lag behind. So let's look into the actual source code of it. So what it does is the forward. Everything else here is asserts, and the main thing is the animate to internal method. And this is a nice way if suppose you've disabled animations, they just limit the animations to a very very small period, so it just happens to be instant, but it's actually not instant. So even if you want to go through the code, it's actually pretty good to just read. And since everyone's locked down, you like everyone has extra time, we can just try something new out. So the main thing here is this method. So if you see start simulation, sorry, um, the method to note here. So start simulation. So first of all, what is a simulation? So a simulation is it's a predictor of what a value would be at a certain point, but not exactly like tweens. So for example, if you imagine, so here our simulation is going to be really simple. It's just going to be so um, for 0 0.5, which is going to be 0 0.5 because so for example, if you have a 1 second duration animation at 0 0.5 seconds, it would the value at y or like the value, sorry, the value at so the return value would just be 0 0.5. If you have a 2 second one, then it would be 0.25. So it just simulates what a value would be over some duration. Now let me give you an example if that's not clear. So you also have spring simulations. So spring simulations, you can actually get uh, you can get the dx or where the spring will be at a certain point. So it will give you, so if you visualize a spring doesn't just go one way. It will it will go forward, come back, and stuff like that. So here, this is an example of a simulation. So a spring simulation, like like the one you use over here, it will go ahead, come back, go ahead, come back, go ahead, come back, and that is how simulations work. They give you the corresponding values at instance in time. So so we have the simulation, and the main thing here is the ticker.start. So what is a ticker and where does it come from? So what is a ticker we've discussed? A ticker just ticks and gives you and updates the animation. So where does a ticker come from? It comes from this thing. So what is the vsync? What is this parameter? Now, if you've played like if you have if you play like high FPS games like I don't know CS:GO or stuff like that, um, what vsync is a way to match the frames of the game with the refresh frames of the monitor itself, so you don't accidentally miss frames out. So here it's not precisely that concept, but it's close. So vsync allows the animation to reload once an internal frame inside the Flutter engine is scheduled. So a ticker is provided a callback. So when this animation controller, it uses one ticker. So a single ticker has just one ticker for efficiency purposes. A normal ticker provider state mixin will have a set of tickers, not just um, it will have a set of tickers instead of a single ticker, and then it'll just create them as required. So when you pass the vsync parameter to the animation controller, that vsync is used to create is it's used to create an equivalent ticker for this animation. And this tick is the most important thing. This variable tick is actually a callback of what should happen when a tick happens. So like when a ticker says, okay, you can go ahead and run something because that's the new tick. This is the main thing. So when a tick occurs, you notify your listeners, and now your listeners are the animations. So for example, the animated builder that we use, the animation that we use over there, that animation listens to this thing. So notify listeners notifies that thing. And then you have some other checks that if the simulation is done. So for example, if the upper bound is reached, then just complete it or dismiss it or stuff like that. So um, that is what it takes. So this tick is a callback and that you have to pass when creating this ticker. So in summary, a ticker is it's like a persistent it's, it's like a ticking clock. So it takes a certain amount of times, and that tick gives a callback to this to the ticker, and when an animation controller creates this ticker, it provides this callback. So when the ticker ticks, the animation controller can finally run this code, which updates your UI. This code. So um, now you have this create ticker method, and you have a tick. In the ticker itself, there's not a lot of stuff, but the main thing is the ticker.start. This is the main thing. So you schedule a tick. So this is the base of everything, which is the scheduler binding. Below this, you go into I think below this you go into like a lot of native code directly. But scheduler binding is the instance that you use to create the most you use to actually schedule the ticks that come along, um, which come back to the ticker. So essentially, this is how the story goes. So you create an animation controller, you call forward. Um, that forward um, that forward create so when you call before when you sorry just let's start again. um, when you create an animation controller, it defines a ticker. That ticker is used in the forward function to actually start the simulation, or essentially just create or just start the ticks that are used over here. Those things schedule the actual frame callbacks required for Flutter to um, actually render the frames again. So this then, so this ticker, when it starts, when it ticks, then the callback is called that we use to create in the ticker. So on tick is called, which is then which it goes back. So the on tick is called, and in the on tick of the animation controller, we over here we yeah. So in the tick of the animation controller, we update the final UI that becomes the animation that we see. So as a total summary, so animation controllers, they create a user ticker values provided by ticker. Yeah, so they use a ticker provided. Um, they're not created tickers. Rather, the animation controller creates a ticker and places it inside the ticker provider, so that with its own defined callback. So the forward function of the controller starts the ticker, and which internally schedules a tick using an instance of scheduler binding. And the last part is single ticker provider state mixin maintains just one ticker, while ticker provider state mixin keeps a set of tickers for animations to access. This is because using a single ticker, you will still have you'll have better efficiency. But note that even if you have multiple tickers, they will, to my knowledge, tick at the same time. They will not tick in series or stuff like that. They will tick at the same time. So as a total summary of what was just said, animation controllers aren't really necessary, but they start the actual process, and they schedule the ticker, so they become necessary because of the ticker part, not because they control the animation itself. If you wanted to, you could create an animation yourself from 0 to 1 that you provide to your normal animation. So yeah, so in this parent, you can just yeah, in the animate method, which expects an animation double, you can just provide a normal animation and be done with it. But then you would have to figure out yourself a way to update these animations, so a way to drive these animations. So an animation controller's main job is the ticker part. It is the 0 to 1 part, even though it is an animation, is just more of a side thing. A tween is the main thing responsible for giving you the values in between beginning and ending. An animation is not. An animation is something of a wrapper around a tween, which actually gives you a way to listen to the tween and update on these animation changes. So since the animation controller changes the animation, an animation can change the animated builder. The animation, one more optimization which the animation also gives is that the animation does not make you actually calculate from the tween and the time of what the value of the animation should be at that point. So an animation adds convenience. An animation controller provides the drive, or actually schedules the UI to, like, the actual schedule the ticks that change the animation state. The tween just define the beginning and the end of the animation, and the animation itself is not, it's just a wrapper, or it's just a convenience over a tween for you to use in your UI, because using a tween directly would be slightly, it would just be awkward, because then you would have to deal with two objects instead of just one. The animation controller takes vsync, and vsync is just a handle to create these stickers, ticker or tickers, depending upon how many of them you need. And the tween.animate method is just a way to provide your parent animation so that you can easily calculate the animation's values. The animation controller forward is just a way to start the ticks of the animation controller, so that everything linked to this start animation controller can then um, move ahead and just update accordingly to this one animation controller. And then the animated builder just accepts any animation that. So the only reason this works is because the um, animation object has allows us to listen to it. So in essence, that's how these components actually work internally. And maybe it's confusing, maybe it's not, maybe it could even use some more depth, but knowing this much really gives you a sense into why these are. And as when I was starting out with these kinds of things, it really made me wonder about why are there three things? Why can't there just be one thing? Why can't a bit do a lot of these things in unison? So when you understand these, it just becomes much nicer. It just becomes much cleaner for you to understand what is going on behind them. And overall, I just think it helps us understand animations as a whole concept a bit better. So that ends my talk for Flutter Day, and I hope you got something out of it, and maybe if you could understand animations a bit like in a deeper sense, I'm glad. So if you want to check out my other work, it would be on Medium, on Twitter, or on GitHub. Twitter, I'm mostly active. GitHub, I have a lot of projects that I do. I'm active for a lot of I'm acting active a lot for some time, then I'm just silent sometime next, and that this cycle just keeps repeating. Medium, I'm mostly consistent, but like some things are slightly slow because of a new project that I have still yet to announce. And my Twitter, just like you can definitely hit me up if you have any questions or stuff like that. So thank you, and hopefully hopefully you'll have a better day, like a much very good day with the rest of Flutter Day 2020. Thanks.